Oh, eighth graders. All right, so today's the day you guys learn about the Pythagorean Theorem. All right, probably the most famous theorem in all of math, in my opinion. All right, gets used all the time in geometry, trigonometry, all sorts of stuff. All right, I've even seen my father-in-law, who's a contractor, use the Pythagorean Theorem. All right, so let's get right into it. So what is the Pythagorean Theorem? All right, well, the Pythagorean theorem is used to find the sides of a right triangle. So here I have a right triangle drawn, and by right, I mean it has one 90-degree angle. All right, and we use the little box here in the corner to show that this angle here is the right angle. All right, so it's used to find the sides of a right triangle. All right, and what it says is that the two legs of the triangle squared, so if I have leg A and leg B, and I square them and I add them together, their sum will be equal to the hypotenuse, which I'm using as C, squared. All right, so guys, get used to me calling A and B the legs of the triangle. All right, and C is the hypotenuse of the triangle. And remember, the hypotenuse is the longest side of a triangle, which is always directly across from the largest angle. All right, so A and B are the letters we use for the legs of the triangle. C is the letter we use for the hypotenuse. All right, and again, A squared plus B squared equals C squared. All right, if we were in a classroom setting, I'd have you guys look at each other and repeat it over and over again. All right, so let's get right into it. So what you're going to do for this first task is you are going to be tasked with finding the hypotenuse. So I'll give you a triangle here, and I'll give you the measurement of two of the legs. All right, in this particular triangle we have 3 and 4, but we don't know what the hypotenuse is. All right, but we can certainly find out. So like I always tell you guys, if you have a formula, write it down. So we start with A squared plus B squared equals C squared. The more we write it down, the better we'll remember it. So we write the formula, then we substitute what we know. We know A is 3, and it really doesn't matter if I call 3A or B or 4A or B. I just know that 3 and 4 are my legs. So I have 3 squared plus 4 squared has to equal C squared. Now I actually perform these operations. So I'm going to take this, I'm going to square 3, which is 9. I'm going to square 4, which is 16. That equals C squared. Now I'm going to sum those. 9 plus 16 is 25. And that equals C squared. All right, and last week's lessons were all about how to solve an equation that looks like this, where you have an exponent of 2. So how do you undo raising something to the second power? Well, to undo raising something to the second power, you take the square root. So I'm going to take the square root of both sides. All right, and the square root of 25 is 5. All right, so 5 equals C. So my hypotenuse is 5. Now remember, when you guys solve equations that have square roots, there's always a positive and a negative root. But in this case, you can't have a negative length. All right, so we would disregard that negative root. All right, so the hypotenuse for this particular triangle is 5. And I chose this particular triangle for a reason. This is called a Pythagorean triple. All right, and what that means is that the two legs, when added together and squared, equal the hypotenuse squared. All right, I stumbled right there. All right, so this is called a 3, 4, 5 Pythagorean triple. All right, it's probably the most famous triple. This is the one I've seen my father-in-law use when he builds things to make sure that he builds a perfect 90-degree corner. All right, let's do one more example where we don't get such a nice number. All right, so again, I've got a triangle. It's a right triangle. If it's not a right triangle, you can't use it. I've got legs of 40 and 35. So I know that A squared plus B squared equals C squared. You guys are going to be going nuts because you're going to write this down so much. All right, eventually you won't have to write down the formula. All right, so we've got 40 squared plus 35 squared equals C squared. All right, I'm going to pull my calculator out because these numbers are huge, or they're going to be huge. All right, so 40 squared is 1,600, 1,600, plus 35 squared is 1,225. That equals c squared. All right, I add these two numbers together. Obviously, when you guys are doing this on your own, you can be a little faster, but I'm just trying to give you guys the gist of everything I'm doing. So I get 2,825 equals c squared. All right, now I can't stop there because c is not alone. All right, when you square something, it really means c times c. So I have to undo that by taking the square root. All right, and the square root, don't forget your square root button on your calculator, of 2,825 is, ooh, that's an ugly number. All right, now what that number is that's a rational. Okay, so when you take the square root of a number and you don't get a whole number or a number that terminates, that means that this particular number is a rational. All right, so there's two ways we could write this down. We could either say c equals the square root of 2,825. All right, this would be like writing your answer in exact terms. All right, that's about as close as we can get. But since this number is a rational, all right, it means it can't be written as a fraction, its decimal form never repeats and it never terminates, you're going to have to round. All right, and I think on IXL it has you round to the nearest tenth. So we could also write c equals 53.2 in this case. All right, so that would be our hypotenuse for this particular triangle. All right, guys, so I hope this gives you a basic understanding of the Pythagorean theorem. All right, don't forget, it's only used for right triangles. A squared plus b squared equals c squared.